Good evening and welcome back to another session of object-oriented programming using C++. My name is Himanshu Gupta and today I'll be covering constructors, copy constructors, shallow versus deep copy in C++. As we have already discussed that a C++ class is defined using the keyword class with some name, suppose test, and it can contain various elements like variables, math functions, constructors, and class itself. Class within class is known as nested class. We call it nested class. So we have also discussed that a C++ class or member of the C++ class can have three types of access specifier or modifier: private, protected, and public. By default, all members of the class are private. The private members, we can only access the private members within the class. We can access the private members only inside the class. Means they can only be accessed using the member function of the class, and we cannot access them directly using the object of the class outside the class, right? Now the second one is protected members. Protected members has little bit higher scope than the private members. They are accessible in its own class as well as in the subclass. Subclass means child class. When we will cover the inheritance, we will get to know what is the meaning of base class, subclass, or parent class, child class, and public members are accessible everywhere in the program. We can use them direct. We can use them directly using the object of the class. Accessible everywhere in the class. Now let's talk about the different members of the class. So some students might be confused that which members we should make private and which part of the class we should keep as public. So the rule of thumb is that the member variables of the class, the variables of the class are generally declared as private and the functions or methods are declared as public. In 90% of cases, 90 to 95% of cases, this rule holds. Now in this particular video, we'll be talking about different types of constructors. So basically, first we'll discuss what is constructor. Constructor is a special method, is a special function that is used to initialize the member variables of the class. The name of constructor must be same as name of class, and it does not return any value. Constructor is invoked automatically when the object of the class is created So this is the basic definition of constructor. We have various types of constructors like default constructor, parameterized constructor, copy constructor, etc. So today we'll be talking about these three types of constructor: default, parameterized, and copy constructor. So basically, default constructor is the constructor in which does not take any parameter. Let's write a simple code. Class test int a. This is the private member by default. This member is private. Let's declare the public section of the class and take a constructor test. This is known as default constructor. As we are not passing any parameter into it, let's initialize the value of a with some default value 0. Test x. This is known as parameterized constructor. And let's declare another constructor test of, in which we'll be passing the reference of the test class, and this is known as copy constructor. So we can copy the value of this object into this current object using ob.a, right? So let's take one function, void show, which should print the value of a, and this is our class test. Now let's declare the main method. Int main, declare the object of test class. Let's create three object of the test class: test t1, test t2, and test t3, and pass the object t2 here. So basically, when the first object is created, it calls or invokes the default constructor, which is the first constructor in our case. This invokes the parameterized constructor, and this invokes our copy constructor, right? Now let's call the show method one by one using all the objects. t2.show and t3.show. Return 0. So I think we can predict the output. The output of this code will be t1.show will print a is equal to 0, t2.show will print a is equal to a is equal to 2, and t3.show will also print a is equal to 2 because t3 is the copy of t2. Now let's run this in our compiler. Okay, in order to save the time, I have already written the code here. So as we just discussed, I have created a class test and take a private member variable a, and I have declared three constructors. This is our default constructor, parameterized constructor, and the copy constructor. This method show is printing the value of a. I have created three objects. This is invoking our default constructor, parameterized constructor, and this will invoke our copy constructor, and we are simply printing the values of a in all the cases. So as expected, the first case is printing the default value of a, that is 0. In the second case also we are getting a is equal to 5, and in the third case also we are getting a is equal to 5. Now the interesting thing here in this example is that the C++ uh, by default supplies its own copy constructor. That means if I even do not write this code, if I remove this code, then also this code will run and we will get the same output. You can check. I have removed my copy constructor code, still I am getting the same code, because by default C++ supplies its own copy constructor and we can use it in both the ways. This is the one way of invoking the copy constructor. The another way of invoking the copy constructor is we can create the object T4 and assign it the another variable, another object, say T2. So this will also invoke the copy constructor, and T4 dot show should print the value of a is equal to 5. So if I run it again, you can see now our four objects are printing the four values of a, and since the last two objects are the copy of object T2, in the last three lines we are getting the same output. Now I think you have understood what is copy constructor. Now the question arises, if C++ supplies its own copy constructor, then why are we why do we need to define our own copy constructor? In which situation we should define our own copy constructor if C++ supplies its own copy constructor? So let us discuss that case. See, if we are using the normal variables, there should not be any problem with the copy constructor. But when we deal with the pointers, the copy constructor will create, the default copy constructor will create the shallow copy of the object, and it will not create the deep copy. So let me uh, give you an example what I mean to say by shallow copy or deep copy. Okay, in our previous example, if we carefully check the code, if we carefully see the code of copy constructor, then what is being happened? See, this is the definition of class test, and it contains a variable a. Right. First we have created a let's right here. This is our suppose T1. Here default definition of the constructor will invoke, and our a becomes 0. In the second case also, for T2 we have passed some values 5, and our a of T2 will be initialized with 5. Then in the third case we have created T3, we have physically created T3 and passed T2. So this OB is basically alias of the object T3, and in the we are assigning a of T3 the value of this alias dot a, which is equal to 5, right? And see, so here in this example, all the three objects will have separate memory location, and all the a are given separate space in the memory. But let's consider one case. If let me take the same example. I will come to this soon. Let's rewrite the code. class test, and now this class contains two variables, suppose int a and a pointer p, right? We all know that pointer is used to hold the address of that type. Let's declare public section and a constructor test. This is our default constructor. Assign the default value of a, and since this is our pointer, we need to assign some space here using the new keyword new int and 0. So this will initialize an integer type of space for this pointer. Basically what this line will do, this will allocate some space, this will create a space of integer type, will initialize this space using 0 and return the address, and the address of this space will be assigned to p. Now let's take another constructor test int x and int y. Now again a is equal to x, create a space for pointer p, means we are creating a memory location, will initialize it with y, and the address of that memory location will be stored in p. New int y. Okay, fine. Now let's create a copy constructor test and pass the reference of this object. Now a is equal to ob dot a, and what we are doing, p is equal to ob dot p. So what will, here we are just copying the pointer. We'll see what will happen here. Then void copy, void show, print the values of a and p, cout a is equal to say a, and let's print the value of this pointer. P contains value at p. Let's print the value at p, and that's it. This is the definition of our class test. Now again let's, in the main method, create the object test t. This will invoke the default constructor, then test 5 and 10. This will invoke this. Now I'll show you this is T1, T2. Now let's create T3 and pass T2 in it. This will create the shallow copy. This will create the shallow copy. This is what I am talking about, and that's it. T1 dot show, T2 dot show, T3 dot show. Now let's discuss what is the problem with this code. Here in this code, we have created three objects, right? So let's create three boxes. This is our T1, T2 and T3. Here we have two variables A and a pointer P, A and a pointer P, A and a pointer P. So what is happening uh, when we create this object T1, the default constructor will invoke, A will be initialized with 0, and there will this constructor will create some integer type memory and will initialize it with 0 and return the pointer. Suppose the address of this location is 1000, this address will be stored here. The value of P will be 1000 if the address of this location is 1000. Likewise, when we have created this object T2, in the same way, A will be initialized with 5, and there, this will this line will create an integer type memory, which will be initialized with the value supplied in the constructor 10, and if the address of this location is 2000, this address will be stored here 2000. The value at 2000 is 10, but this our pointer will be storing this location 2000, right? Now what we have done, we have in the third case, we supplied this T2 object in this in the copy constructor, and what copy constructor is doing, it is copying A with A will be initialized with 5, and P will now contain the same address 2000. So here what is actually happening, the A of T3 and A of T2, this is T2, the variable A of T2 and variable A of T3 have separate locations, but the pointer P are pointing to the same memory location. I mean to say that there is a location which contains the value 10, and suppose its address is 2000, then both of these pointers T2, P of T2 and P of T3 are pointing towards this memory location. So it does not have its own memory to contain the pointer P. So what will happen if we call the destructor? If we call the destructor, like constructor, C++ has C++ also has destructor, and destructor is declared like this using a tilde sign and the name of class. This is the destructor. By default, uh, C++ supplies its own destructor, but if you have uh, allocated the memory using dynamic memory allocation, then it is mandated to deallocate the memory using free or delete function, right? We use two type of functions For dynamic memory allocation, we use malloc, which is a C++ function. We can also use calloc, which is again a C function. Both of these functions are C functions and returns a void pointer. They returns a void pointer, and the memory allocated using these operators, using these functions, can be deallocated using free. While if we are allocating memory using new keyword, then it should be freed using the delete keyword, right? Though C++ supplies its own destructor, but if you have used dynamic memory allocation method like new, then we should delete it using the delete keyword. When we need not to explicitly call the destructor of the destructor of the class is automatically called when the object goes out of scope. So when the object goes out of scope, the destructor is called automatically, right? So basically what will happen here in this case, if inside the destructor, if inside this destructor I try to delete, I try to delete P, then what will happen? Basically, first we have created three objects, T1, T2, T2 and T3. If this goes out of scope, this will be called, there will be no problem. This, if this goes out of scope, see T2 and T3 both have P which are pointing towards the same memory location, which are pointing towards the same memory location. This will try to deallocate the memory for the first time. The operation will be successful, and when this T3 will go out of scope, this will again try to deallocate the memory which has already been deallocated by the destructor. So there will be a warning message, there will be an error message, and let's see this code that we have just discussed in our uh, online compiler. I have already written the code. So like I just discussed, this is our uh, class. I have taken two variables. One is integer type and the second one is integer type pointer. We have, I have in the same way I have taken three constructor. This is our first constructor, default constructor, second constructor, and this is our copy constructor. So this is our this copy constructor of ours is doing the shallow copy. Shallow copy is creating the shallow copy because we are simply copy pasting the uh, address from one location to another location, and we are not physically allocating the you know space, extra space or separate space to store the variable. This is our constructor, this is our destructor, sorry, this, and if I run this, suppose, first let's not delete this pointer p, and let's try to run this. So you will see that a, these are our four objects. A contains, a is equal to 0, p contains 0, a is equal to 5, p contains 10, 10, 10. We have created three copies using copy constructor, and we have created four objects, and four objects are deleted successfully, right? So there is no issue till now. But if I try to delete this pointer P, then what will happen? Double free detected in cache 2, T cache 2. Object destroyed, and then after when the second object tries to free the already deleted space, already freed space, it is giving us a message and the program finished with exit code 134, right? So this is the problem with the shallow copy, with the shallow copy of the object, and its solution is the deep copy. Its solution is the deep copy. So let's see how we can implement the deep copy. Basically, what we have done in our last shallow copy constructor, the shallow copy constructor was implemented like this: a is equal to ob dot a, and we have not created any new memory for our pointer p, and have simply copied the value of uh, the address contained by the p of this object into our pointer, right? So what is the solution? This is shallow copy. How should we handle it? We should handle it like this: test, test. This line will be same. Okay, now allocate some memory to P. Allocate a new memory location for this P using new int. Since this is our integer type pointer, we have created a separate memory location with suppose address 1000, and now this P contains this address. And now what we can do, we can say, we can write value at P. Value at P means the address contained by the P. This is the P will be equal to value at ob dot P, right? So whatever address key variable P pointer of this object contains, it will be copied here. So suppose this is OB and its P contains address 2000, then here P will be 2000. So you can see that now we have made a separate memory space for our this pointer, and therefore there should not be double delete error in this case, and this constructor is known as deep copy constructor, right? So whenever with the normal variables, you know, our copy constructor will work fine, but when we are dealing with the pointer, when we are having pointers in our code, we should supply our own copy constructor, which can make a deep copy of the variables. So I think this tutorial has cleared your doubts regarding shallow copy and deep copy. Let's make a deep copy here. P is equal to new int, and value at P is equal to value at object dot P, and this is now working absolutely fine. You can see there is no double delete error and all the objects are destroyed successfully using the destructor. So this is the deep copy. Thank you very much for watching. In the next video, I will come with some another important topic of C++. Till then, bye bye.